Hi everyone, welcome back. I hope you watched the last video where we talked about knowledge graphs. In fact, it was an introductory PowerPoint only video about knowledge graphs, and this is a follow-up video, obviously, where we focus on using Python, especially NetworkX library. I say obviously because it's on the screen there. The goal for this video is to go through the basics of NetworkX library and slowly get familiarized with the concept of knowledge graphs. What can we do? And at the end of this video, you should get a very good understanding of the concept of knowledge graphs and how do we add nodes and edges and perform some basic analysis of a knowledge graph. So I hope you're excited. And again, in the next video, we are going to build on this topic and focus on a specific topic, again, within the knowledge graphs. And we'll probably, again, I haven't thought about what exactly to do, but I'm thinking about in the next video, let's build a knowledge graph, using for example, my own video series from these YouTube tutorials and querying them to extract certain information. So if any of these is interesting, to you, go ahead and hit the subscribe button so you get notified, or at least it's in your subscription list, when the new video shows up. And while you're there, try to find the thanks button if you're feeling extra generous. Okay, so I think it's time to jump into our code, and I'm going to use Google Colab because all of you can easily access it. So let's go ahead and start with Python. Okay, and I'm not using any GPU in my runtime because we don't need it, at least for what I'm planning on showing you. So don't waste GPU resources by just choosing that for your runtime. Okay, with that information, let's scroll down. So the two libraries that we need, at least for today's exercises, are NetworkX, obviously, and PyViz. And PyViz is for visualization. So let's go ahead and install it. And it should be pretty quick in general. And now let's go ahead and have a quick look at how to initialize your graph, right? So obviously import your NetworkX and with a alias of NX, which is customary. I'm importing pyplot from Matplotlib for plotting. As you can see down here, we're going to plot using Matplotlib engine. Okay, now how do you create a graph? Like first, the way you create these graphs is you create a graph space, like a graph, and then to the graph, you're going to add nodes and edges and all that information. So let's start from absolutely nothing, right? So you create a graph by calling it G is customary. You can put anything, but most people use G to define a graph, and most people use DG to define a directed graph, right? Remember, directed graph has these edges that are pointing from one node to the other in a specific direction, so they're not bidirectional. Otherwise, it's a regular graph. So a regular graph is nothing but nx.graph in parentheses. So that's how you create a graph. A digraph, which is basically a directed graph, is very similar, nx to nx.digraph. Okay? So far, so good. Now for visualization, most of the time we follow the structure, and as we add more and more elements, we will have to add more code for our visualization, but I'm not going to dwell too much on visualization part. That is the easy part that you can get, just ask ChatGPT to give you a visualization for something, right? So I want you to understand the concept of graphs, how you use NetworkX to generate these graphs and everything, and you can build on top of it, obviously using your own personal topics, using your own personal research. Okay, so we defined a graph and directional graph. And how do we visualize it? First, I define a space for our visualization and then actually add a graph to that specific space, right? So that is nx.spring layout. So I'm defining the layout. And there are many different layouts that you can use to actually perform your plotting. In fact, in some, you can actually define the physics, like how to move these graphs and all that if they're interactive. We'll learn about those, in the next 2-3 videos as we actually focus on specific applications. But for now, okay, we define this, and then you're drawing your graph, you're placing your graph in that space. Think of it that way, and then you're just showing it. Now here, when I run this line, I should see nothing because this is an empty graph with nothing, no nodes, basically nothing. So the next step is to actually add nodes and other information. So that is exactly what we're going to do here to our graph. Again, I'm working with our existing graph that we just created here, right? So G, forget DG, the directed graph for now. We are just going to focus on the graph part, G. So now that I defined a graph, G, I need to add nodes, or I can add nodes and edges. So here to add a node, it's basically g.add_node and give a name to it. So in my case, I gave the node name Python basics. So the graph I'm trying to build here is a graph of Python learning. So you start with basics and then you go to data structures and you go to advanced Python. So this is how we plan on doing. So the first node I want to add is Python basics. Well, you can add one node at a time, or you can define a list and then add nodes from. So here you can actually define my nodes equal to and then create a list and then g.add nodes from my nodes or something, right? So I just defined a list right here. So you add the nodes from a list. And visualization is very similar, Spring layout. And now I added a third parameter to the draw method here. The third one is with labels equals to true, which basically, as you can imagine, shows the labels when it actually does the drawing. So let's go ahead and run this. It adds nodes, and it adds nodes from data structure from this list. So it should have added 3 nodes right now: Python basics, data structures, and advanced Python. So there you go. Where they're placed doesn't matter. I know it's like, okay, so the data structures is here, advanced Python is there, Python basics is here. In fact, if I run this again, the positions may change, because in a graph, the positions don't mean much of anything, because the connections is what's important, right? I mean, you're not placing the graph on an actual graph grid saying, hey, this is the spacing and all that. So this is not like a graph that you do on a graph paper. So okay, so these are added, and you can see the labels equals to true. So it's kind of truncating the labels. We'll change these later on, but you see how the nodes are added, right? Now next comes edges. How do we add an edge? So you have advanced Python here, and you have Python basics and data structures. Let's actually connect Python basics and data structures. As you can imagine, just like you added a node, g_add node or add nodes from, adding edges is extremely similar, add_edge. And now we are adding an edge. Remember, for edge, you need to define 2 nodes because we are connecting these two. An edge is basically a line that's connecting 2 nodes, right? So we want an edge between Python basics and data structures, and then the visualization equals basically the same part of the code right there. So now when I do that, you should see that advanced Python is up there, and Python basics is here, data structures is here, and there is a line right there. By the way, like I said, if I run this again, possibly you see the advanced Python is here, and these two are here. So where they're placed is completely random. You can kind of, define additional parameters to make sure, okay, they show up in one way or the other. But for now, if you don't define anything, just Spring layout, each time you run, the node positions are different. You can make it interactive. We are going to use PyViz later on, but this is just PyPlot that we are using, Matplotlib. Okay, we added an edge between these two. So far, so good. Now, next, let's go ahead and add edges from, right? Remember, we did add nodes from. So if you have a list, then you can use add edges from, and this is a list, but each of these is a tuple, right? So data structures and advanced Python, that's a tuple. So the connection is between data structures to advanced Python to machine learning, and then we are plotting. So remember, we are adding it to the existing graph G. We are not redefining the graph. So we're modifying the existing graph, so we should see all the connections from before and the new ones when it plots. So there you go. So it has Python basics, data structures, advanced Python, machine learning. By the way, you can define certain parameters right here to not make this a straight line, the plot. You can say, hey, bend it here or whatever. There are certain ways to control this, but at this point, it's okay. So you're going for, these are all connected, Python basics. Again, this is not a directed graph, so these are just connected by a line. Python basics, data structures, advanced Python, machine learning. I hope so far, so good. We added nodes, we added edges, okay? So there you go. That's a nice visualization of your graph, but how do you convert that into a knowledge graph? So far, this is basically a graph. What does that mean? You connected Python basics to data structures. Okay, so what? Where is the semantic information in this graph? That comes from your knowledge graph. So how do you define a knowledge graph? Well, let's define a knowledge graph now. Okay, so let's say our topics, which is we are going to add attributes to our nodes. Remember, we have nodes Python basics, we have data structure, we have advanced Python. I'm adding another node machine learning. And to these, I'm adding attributes. One attribute is difficulty, and the other one is description. So let's say the difficulty here is beginner, and then intermediate, and then advanced and expert, right? So for these 4 topics, and the description, appropriate description to whatever they are. This is what we mean by semantics. Additional information that kind of gives context to the graph. So we just added that by calling topics. Well, we just defined a dictionary of dictionaries, here called topics. But we need to basically add that, to your graph. So that's what we're doing down here. So for node and attributes in this topics.items, right? For node and attributes, you need to go ahead and add these nodes and update the attributes. Okay, so these nodes, for each of these nodes, the attributes, you're kind of updating them. So that adds these attributes. Now you can, this is for nodes, and for edges it's exactly the same. So for edge attributes, again, you have a dictionary right there. And what edge are we talking about? Remember, edges is always defined by a tuple where you have the 2 nodes defined right here. And then to that, add a weight of 1.0, and then say, is this prerequisite? True. Is that a prerequisite? True, and so on. And let's look at the visualization, and then hopefully things make more sense. And weight is just, again, how important is it, for example, in this case. So now, again, for edge and attributes, for each of these, in these items, we are going to, for each edge, we are going to update the attributes. Very similar to how we updated the attributes to your node. Okay, now it's time to visualize. Again, as usual, we define the Spring layout, and we draw the graph with the positions, sorry, not with the positions, with this variable right there. And let's also add labels to be true. And then on top of this, we are adding the node attributes. I added an offset, otherwise it was like falling onto the node, and it's a bit difficult to read, but it doesn't matter. I mean, this is basic plotting right there. Okay, so I'm adding the node attributes, edge attributes to the plot, and we are going to draw the labels with these edge labels and whatever the font size. So hopefully you should see this right there. Okay, so this is our plotting. So Python basics, data structures, these 2 are connected, and the weight is 1.0, and the prerequisite equals to true, which basically, when later on, when we do some sort of a prerequisite analysis, when say, hey, if I want to do data structures, is Python basics a prerequisite? It should return true. Or when we do analysis saying, okay, I want to do advanced Python, what prerequisite should I complete to do this? Then it looks at the prerequisites, and it's like, okay, so these are the prerequisites. So this is one way of interpreting this. Make sense, I hope. And all this plotting stuff, add labels and all that, is to make sure we kind of show that visually here. Obviously not needed if you want to do analysis only and not just plotting. Okay, now with that information, let's build a learning path, right? So now all of that, basically we are putting the story together at this point. So we know that we have certain topics, Python basics, difficulty is beginner. I'm not adding extra attributes here. You can if you want. And these are the topics, and these are the relationships, right? So Python basics to data structures, and weight is 1.0, and so on. And I'm creating a digraph now, not a regular graph, but a directed graph. And that's what I mean by building a learning path. So now we need a path that goes from one topic to the other. Remember, I didn't just do Python basics and data structures in a tuple and say go ahead and add an edge. I'm defining 2 dictionaries, sorry, one dictionary here, and then another list of these tuples here. And let's build a directional graph. Okay, so how are we doing that? Okay, for each of the topics and metadata in your topics.items, which is basically this part, right? So we are referring to that. We are adding a node. This is no different than how we have done literally a few seconds ago. So we are going to add those, and then we are going to add edges from, because this is a list where we have a tuple, and within the tuple you can actually add a dictionary for to defining weights right there. So that's how we are adding these edges. It's very straightforward. And now it's a matter of plotting, drawing, whatever you want to call that. And here I want to color different nodes in different colors. Like if it's a beginner, meaning if my Python basics, if the difficulty is beginner, color it with some color. Intermediate sky blue and advanced is orange. Okay, and I'm going to give these colors right there whenever, well, I'm converting that into a list right here. And then when I draw, I'm giving that with labels equals to true, and then how to color each node, go ahead and look at the color list, because that assigns to each node based on the difficulty, based on the difficulty we defined here. It's like, hey, Python basics, it has beginner difficulty, go ahead and color it with light green, right? So that's the list I'm actually providing down here, the color list. Or you can just define a list yourself and provide it. And all the other stuff is pretty straightforward. Edges in gray. And now adding the labels, go ahead and add the labels, and now adding the legend. So this is all plotting stuff. So but the key lesson I want you to learn, the plotting stuff, you can go through it later. The key lesson is the directed graph right here. And then you're actually providing this information of topics as a dictionary of dictionaries, like we saw earlier, and relationship as a list of tuples, and each tuple containing the edge from edge to, because this is a directed graph, right? It goes from Python basics to data structures with a weight of 1.0. This is how you define a directed graph, and then we are actually plotting it. So let's go ahead and run it. By the way, all this code is available. You look at the description down under the video and you'll see the link to this code, and there you go. So this is our learning path visualization. So you go from Python basics to data structures, weight 1.0. Remember, we assigned it, right? We assigned this. All we're doing is defining a graph and plotting it. Okay, and data structures to advanced Python. You see this arrow? The arrow tells you that this is a directed graph. This is a directed graph. Yeah, this is overlaying here. That's okay. Okay, so far you learned how to add nodes, how to add edges, how to define a directed graph, and how to connect, basically with when defining directed graph, how to actually connect two nodes and assign weight to these nodes. Now let's start by learning how to perform basic analysis in these graphs. There are many analysis methods, but let's just start from the basics here. Okay, so now that we have this graph, let's go ahead and get the number of nodes. And that's as simple as G is our graph. Oh, why am I doing G and not DG? That's okay, it doesn't matter. G here is the graph that we did earlier, not the directed graph. Oh, I think we called it, I should have called this DG. Anyway, we redefined this anyway, so this is our directed graph anyway. So ignore what I just said earlier. So basically we are analyzing what we built here. I did a mistake by not calling it DG. Typically I call it DG, but anyway. So typically I call it G, which I ended up doing anyway, but when I created this video, I wanted to call it DG. Okay, I wasted like 2 minutes talking about why I did something stupid there. Okay, so this is our directed graph, and even if it's directed or undirected, regular graph, it doesn't matter. Number of nodes, number underscore of nodes, number underscore edges, that's what tells you how many nodes you have. And node neighbors, you can actually say G, your graph, dot neighbors, and then neighbor to what node. Give it the name of the node. It tells you, hey, what are the neighbors to this specific? Neighbors are the ones that are connecting to or connecting from. Okay, and also you can get the degree of the node. Degree is how many is it connected to. incoming and outgoing. So let's go ahead and print all of these. So number of nodes 4, we know that. Number of edges 3, right? 1, 2, 3, 4 nodes, and edges 1, 2, 3. Number of edges is 3. And what is neighbors for Python basics? So what are the neighbors for Python basics? There should be only one. Data structure is the only one neighbor to Python basics, so it should give you data structure. So if I put data structures here, it should give you the neighbors on the both sides. And get the node degree. So what is the degree of data structures? So data structures is right here. The degree is 2 because one is incoming, one is outgoing. So the degree is 2. You can also say how many incoming versus how many outgoing and all that, but that's again, we can explore it later. So basic analysis, okay? Now there are many more that NetworkX actually offers, so go ahead and explore them. I'm showing you the most common ones, at least the ones that I end up using quite often. Graph algorithms. Now let's look at some algorithms that it actually provides, and why do you need these algorithms? Well, you want to find, it's not just like how many nodes, right? I mean, what is the shortest path from one node to the other node is one thing that you can probably find useful. And centrality is another one. Which one is center? In the last tutorial, I gave you an example of something that's central. Like for example, if you have a subway train system map, and there is like one subway system that's like where all trains kind of go through, and if something happens at that node, then the entire train system shuts down, because obviously this is very important. Everything has to go through here. So that defines the centrality. There are many ways of centrality. There is betweenness, centrality, and I think I have we'll learn about those later on, because there are different types of centralities, as you can imagine. One is how central is it to the whole network, or how central is it to some local neighborhood, and so on. Okay, so that centrality is one thing, and there are many other networks. So let's again start from scratch here. We are defining the network because we have done so much. I don't want to mix different topics. So let's say this is from scratch. Okay, we are importing our NetworkX and Matplotlib, and our topics, we have 5 nodes in this case. So the top 4, the previously defined, and I added another one called deep learning, and difficulty is advanced. Okay, so again, these are dictionaries of these dictionaries right there. And then relationships is our edges, and these are tuples that has at least these 2 plus the weight. Yeah. So, and we have 4 edges, right? 5 nodes, 4 edges. You can have many more edges, but 4 edges connecting these 5 in a straight line in our case. Not when I say straight line, connecting them together. And we are creating a directed graph again. I call it G out of habit. And for each of these topics and metadata, I'm going to add node, and then I'm going to add the edges from these relationships. That's it. This is the normal way of defining your graph. And then you can go ahead and perform your analysis. Now, what shall we do? Find the shortest path, including another path for demonstration only right here. So shortest path 1, so you can understand what's going on. So shortest path 1 is between Python basics to machine learning. So maybe we need a complex graph to see that, but Python basics to machine learning all the way to the end. What is the shortest path? Well, it has to go through all the nodes. And what is the what else do I have? And what is the shortest path from Python basics to deep learning? You can also have a look at that, and then we are printing those. And the next example, by the way, the shortest path is nx.shortest_path. I love how this is just like reading English. Shortest path is shortest path. Betweenness centrality is betweenness_centrality. So there is no cryptic way of doing things. If you know what you want to do, you'll probably remember what the command is right there. Yeah. So nx.betweenness centrality. And betweenness centrality is something I use quite often. That's because it is, did I write it down? Oh yeah, right there, I can't even see. It's a measure of a node's importance based on the number of shortest paths that pass through it. How many shortest paths are passing through it is basically betweenness centrality. So in our case, other than the edges, other than the end points, I should say, the middle ones, they should all have the same betweenness centrality because they're all connected to 2 shortest paths. I think we'll look at that. So basically nodes with high betweenness centrality are important for connecting different parts of the graph, right? So in our subway example, this central junction, where all trains go through, that will show highest betweenness centrality in this example, because they act as bridges between, multiple nodes. Now, you can see if a graph is connected. So is it connected? As the name suggests, is it connected? Is it not connected? So that is nx underscore is connected, as you can imagine. And what are we doing here? Yeah, the next part is just plotting. We're just defining the spring layout and assigning colors to the nodes, so it makes it easy for visualization. And basically this is all visualization part. So when you're drawing it, nx.draw is drawing the actual graph itself. Now on top of that, you can enhance it. Hey, when you're drawing, add this highlight. So draw NetworkX nodes. Okay, so that is something that you are actually highlighting right there. So you can control the finer details, like node color, I want it to be red, and node list equals to shortest path 1, and we get that node list shortest path 1. Are we getting it right there? So basically, Python basics to machine learning, when you get that shortest path, go ahead and show that in red color is what we are trying to show here. And for the shortest path 2, go ahead and show that in blue, and so on. So everything is simple, methodical, as you can see. Yeah. These are network edges, and then you can have draw network edge labels. Go ahead and add the labels. That's why I'm not spending too much time talking about plotting, because I don't know what your requirement is. But in this case, let's go ahead and plot this. So it says shortest path 1 from Python basics to machine learning is basically this. You go from Python basics, data structures, advanced, basically the entire thing. The entire, going through each node. For the other one, it basically should stop at, right there. So data structures, advanced Python, machine learning, and deep learning. If you want to go, that's the shortest path. And this is this betweenness centrality. The edges, you don't have any betweenness centrality, 0. And then as you go in, the more center it is, the higher the value is going to be, right? So here you have 2 neighbors. Here you have 3 edges connected, and here you have again 2, and here you have 0. So advanced Python in our graph is the one that's in the middle, and as you go farther and outside, it's less central. So that's what this is. So I hope that makes sense. There are other types of centrality, and I tend to confuse some of these, so I always go back to betweenness centrality is something I use all the time, but other ones that I show you later on, I don't use them quite often, so I have to go back to the documentation all the time. Okay. Again, we already talked about betweenness centrality and graph visualization. I did the mistake of plotting something in red and overlaying something on top of it, so you don't see that anyway. But you see the blue lines here. It's showing you the shortest path for the second one. So it's in blue. Okay. So there you go. So that shows you the type of analysis algorithms you can actually run once the graph is built. We'll look a bit more about centrality in a minute, but now that you have a graph, how do you save it so you can work on it later on? You don't want to kind of plot, create graphs all the time. Well, for a small graph like this, it doesn't matter, but if it's a large graph, you want to create a graph and then query them later on by loading the graph, right? So how do you store this graph data? You can store them as NetworkX native, which is okay for small graphs, temporary storage and all that stuff. SQL database is, again, something we will do in the next tutorial. You can store them as graph databases. I don't have access to Neo4j. It's a paid one, so I'm not going to show any of the graph databases, at least in the next 3 tutorials or 4 tutorials. And which one do you want to choose? Again, if you have access to Neo4j, I would say use that, especially for larger graphs. But for smaller ones, SQL database is fine. Or NetworkX native is also okay, which is what we'll see in a second. Okay. So, so far we have a graph, right? It's called in a variable G. So I'm going to write the graph ML. Okay. in a as this file name, learning underscore path.graphml. I should have given that some, since I'm on Colab, should have given a path to my Colab, sorry, Google Drive, but it's okay. This is temporary anyway. So this is how, I just want to show you how to do this. So this is how, and storing in a SQLite, this is just a example, but we'll do this in the next couple of tutorials. Subscribe, you'll know when that tutorial is out. Okay, so when I write this, it actually writes this into a graph. What does it say? Primary key, metadata, text. Not sure exactly what's going on. Oh, it's just a screen output when it's actually saving it. So that's fine. So it should have saved this probably if I go to the left here. Yeah, there you go. Learning underscore path.graphml. I haven't connected my Google Drive to this notebook. So that's probably why I chose to do this locally. So once it's there, then go ahead and I think it's read GraphML to go ahead and read it and then perform queries on top of it. But yeah, now you know how to save it. Let's close the left-hand side and continue. Now, there are a few advanced metrics I want to cover. I know the video will get a bit long, but this is one file that you can use to refer, go back, if you want to refresh your memory on the basics. So I'm going to include a couple more aspects, including centrality. So that's exactly what we're doing right here. I'm creating exactly the same graphic again here, okay? And directed graph, same lines of code, no point in explaining. Now let's go ahead and look at the calculating the centrality measures, okay? So first thing, there is something called, obviously we looked at betweenness centrality. There is something called degree centrality. It measures the number of edges connected to a node. And nodes with higher degree centrality are well connected. That's what that is, degree centrality. Betweenness centrality measures how often nodes lie on the shortest path between two other nodes. So this is more useful, in my view, for most scenarios. Again, it comes down to exactly what the scenario is. There is another one called closeness centrality. As the name suggests, you can say how close a node is to all other nodes. Okay, so it's based on the shortest path. So these are the ones, and we are defining them, and all I'm trying to do is print them and plot them. So let's go ahead and look at the output. Close centrality and plotting. So degree centrality, Python basics actually previously in betweenness centrality, it had 0, right? Because it didn't have, it falls on the outer edge. So usually a value of 0 in both betweenness and closeness centrality. Now, as you go closer to the center, the value increases, but you see how degree centrality shows a value of 0.5 for data structures, advanced Python, because they're all connected to 2. 1/2, 0.5 is what it is actually showing. Yeah. So, betweenness centrality in this case and closeness centrality is giving you pretty much the same result. And there you go. That's it. I mean, it's just a plot showing you. I just plotted them based on the strength of degree centrality, and the stronger degree centrality, the darker blue shade it shows up, and the lighter. So Python basics lighter and deep learning lighter, but all the center ones in degree centrality have equal value of what was that? 0.5, I believe, 0.5 right there. And Python basics 0.25. These edges are 0.25. Okay, so I think it's basically 1, 2, 3. Yeah, so it's 1, 2, 3, and 4 edges, right? And this one is connected to one edge. So 1 divided by 4 is 0.25. That's what the degree centrality is. And the data structures has 2 of the edges connected, and 2 divided by 4, 0.5. That's what it's actually showing you right there, in case you wonder. That's what degree centrality is. Okay, so for more complex ones, you can imagine how the values can be much smaller. Okay, a few more about algorithms, since we started talking about algorithms, and then I'll stop this video. I'm pretty sure it's getting a bit long now. So there are a few other things called, for example, community detection, like it find the related topics in the community detection. So maybe there is a video about spatial transcriptomics. There is a video about how to perform another, RNA-seq type of analysis. They're all very similar, so they should be clustered, they should be together. So that's what community detection kind of helps us in detecting. Path analysis showing all possible learning routes, and cycle detection finds what are the circular dependencies within these graphs, and components help, basically to identify any isolated subgraphs that you have in your major graph. Like, hey, there may be different subgraphs that are not connected to anything, but they're connected within themselves, like a few of the nodes, and components can help us in identifying those type of subgraphs. I don't think we'll have anything like that based on how we defined. So let's define the same thing. The top is the same, and here what did I do? I removed the edge causing the cycle. Okay, so basically I removed this because when you go, initially I added, you see, you go from Python basics to data structures, and then to advanced Python, and then to machine learning, and then to deep learning. I was actually connecting deep learning back to Python basics, which makes it circular, right? I just wanted to demonstrate, I removed it. But all the others, for example, community, there are many ways, again, algorithms, just like centrality, betweenness centrality, right? And a couple others that we saw earlier. When it comes to community, there are a few ways, and I'm showing you greedy modularity communities right there. And again, it groups nodes into communities where nodes within the same communities are dense. And there is, I already mentioned about that. So basically, we are looking for communities right there. And how do you do that? nx.community.whatever the specific algorithm is, run on the graph. And then it gives you, now you need to unwrap that to go ahead and print, what communities it's actually showing. So that's what that is. Path analysis, again, a few ways of actually doing path analysis. Here I'm showing you all simple paths, and Python basics to machine learning. So show us all simple paths from Python basics to machine learning. Again, this finds all possible paths between these two nodes. If you have a linear one like we do, then it's just one possibility, but then there are many ways to get to that point, right? So how can I go from point A to point B? Show me all possible paths, and that's exactly what this is. Once it shows, then we can basically say, hey, you want to go from path A to path B? Here is the shortest way. Here is the longest way, right? So then we can decide what to do once you find all paths. Yeah, and cycle is basically simple cycles. Go ahead and detect the cycles. Nodes can return to themselves by following edges. So cycle, as the name suggests, you start with a node, you go somewhere, and then you come back to the same node. If there is a path to coming back to the same node, it gives you that cycles right there. And components, again, connected components. I'm using this connected components to identify the disconnected graphs. So the connected components, hey, it goes through all the connections, and then it says, hey, these are not connected, and it tells you what these components are. And I'm plotting it. So let's go ahead and look at these. There are many, many, many more methods as part of NetworkX. I'm showing you a few that I use. Okay, so what do we have? Community detection. This is what did we detect? Community 1 is advanced Python, deep learning, and machine learning. Community 2, I should have written what we are trying to achieve here, like Python basics, data structure. So these are the communities, all possible points. The path analysis is all possible points. So what are the possible paths from Python basics to machine learning? There is only one, right? Python basics, data structures, advanced Python, machine learning. This is one path. If you have like multiple nodes, a more complex graph, which we'll see next tutorial, then it gives you all the lists, all the possible paths right there. Cycle detection, well, no cycles detected. Obviously, this is a linear, there is no cycle. You cannot start at one node and come back to the same node. So no cycles detected. Connected components, there is only one connected component, which is our entire graph, because there is only one path right there, right? I mean, this is it. There is no cycle, nothing going on. And this is all connected, one connected. If you have another isolated node, it would have given us both. Okay, I think Okay, I think I'm back online now. Sorry about that. The recording program, crashed, so I had to restart, and I think this is where it stopped. So we just did this part where we looked at the previous graph, and I was about to start the other examples, and this I promise this should be the last one because I don't have like a lot of space on my hard disk, and I think I should clean it up at this point. And the program reached the limit and it kind of crashed. I had to clean up and come back. So I'll keep this short and sweet, hopefully, a few more minutes. So because I really want you to see the last part, and then we can kind of close this. Okay, so a few other examples. We are going to define the same topics again, the same thing. This part is exactly same as the previous one. I removed the cyclic link or edge right there. So this is not a cyclic edge, the graph anymore. And we are going to define exactly the same way a directed graph. And what I want to show you here is a couple of aspects, algorithms, if you want to call them. First of all, similarity. Like if you have a topic, you're like, okay, I have a topic called data structures. Like how similar is machine learning to that? If you want to do that, and how does it do similarity? Similarity between two nodes. Let me just do this so you can read it. So measure the similarity between two nodes based on the proportion of shared neighbors. Like how many shared neighbors do they actually have? And then that's basically what we call similarity. And for that, we use something called Jaccard coefficient. Yeah, it's the same Jaccard coefficient that you use in your loss functions, for example, in deep learning. So NetworkX actually offers Jaccard coefficient. And we are, in this case, I'm saying, okay, oh, by the way, Jaccard coefficient only works on undirected graph. So that's why I converted my graph G to undirected right there, G undirected. And then, excuse me, I'm saying, okay, so how similar is machine learning topic to data structure? So the data structure and machine learning, what is the similarity between them? Yeah, so it's basically giving me the similar topics. I think the answer is, I don't know, 0.2, 0.3, whatever it comes up with. The other algorithm or method that you can apply is called ancestors. It tells you the prerequisites. For example, if there is a learning process and then there are certain prerequisites, they are ancestors, right? So because these are directed graphs, so you are right here and then your ancestors, the hierarchy, and it's basically printing out the ancestors right there. And descendants is exactly opposite of ancestors. It's what comes after you. So those are the two I use. In fact, ancestors is the one I use quite often in my Python learning journey process, and Jaccard coefficient is something I kind of use. And yeah, let's do that. And of course, finally here, I'm just showing you the length of this descendants right here because it kind of tells you affected topics if a node is removed, right? If you remove data structures, what topics are affected? If in the subway train example, if you remove the key subway where everything goes through, for example, in San Francisco, downtown, you have Montgomery or Powell or Embarcadero, these stations, if something happens there, some police activity, then all lines kind of are basically shut down, right? Everything has to go through here. So how many different things are affected is what I'm actually showing you here. The rest of it is visualization. So let's go ahead and run it and let's see what we get. Okay. So let's scroll to the top. Other than my print statements, nothing there. Graph without cycles. I'm just printing the connected graph right there. But what we care about is the similarity there. So the similarity between two nodes, between data structures and machine learning seems to be 0.33. Data structures and machine learning. So data structures is right there. Machine learning is right here. Both of these actually share this one, advanced Python. So overall, it gives you a value for Jaccard coefficient 0.33 between these two. And prerequisites for machine learning. What are the prerequisites for machine learning? If you look at the machine learning right there, prerequisites are advanced Python, data structures, and beginner Python or Python basics, right? So that's what it should give you. For dependent topics, descendants, then it's basically all of these. And what else do we have? Yeah, So impact of removing data structures. So if you remove data structures, 3 affected topics basically, right? So you're going in this direction from Python basics, you're going to data structures. If you remove data structures, Python basics is not affected because these are directed. The ones that are downstream are affected, right? So if something happens at Powell Station going, in the East Bay direction, then all the stations on the East Bay are affected and not the ones in the San Francisco side, right? On the San Francisco side. So that's what this is. Similarly, these are directed, basically. That's what this means. So if data structures is down, then 1, 2, 3. 3 of these are affected. And that's basically what this is printing down here. 3 affected topics. 3 stations will be affected in this case. Okay, that I did not expect this to be this long. I thought of actually covering some aspects and then just giving you the code for you to figure out. But as usual, I end up talking way too much. But I seriously hope you learned something from here. And in the next tutorial, let's actually build on this. And again, these are like the next 2, 3, 4 tutorials are all going to be focused on these knowledge graphs. So please hit the subscribe button, come back for the next tutorial and learn more. Thank you.